Hey everybody, Dr. A here, and in this video we're going to be providing some background information and some formula derivations for the constant head permeability test. So what is the constant head permeability test? Well, it's a laboratory experiment that we can perform to determine the hydraulic conductivity or coefficient of permeability of a soil sample. And again, it's in the laboratory. So how does it work? Well, what you have is a cell with your soil sample in it, and it's usually a cylindrical cell. And inflow of water is adjusted such that the difference in head between the inlet and the outlet remains constant during the test period, okay? So what we mean by that is you have a cell here with soil in it, okay? And you typically have, some porous stones on the top and the bottom of the soil sample, and you have this inflow of water somehow, okay? Inflow of water, okay? And so the sample becomes, saturated, all right? So we can put a little, water line here, saturated, okay? And what you do is you adjust this inflow of water such that the head, which we're going to call H, remains constant between the inlet and the outlet, okay? So if you have an outlet here, okay, let's say we have some kind of outlet here, and you can do this by having piezometers attached, but you achieve a constant head, okay, where we're going to say H is the constant head, and it's usually measured from a piezometer that's attached to the apparatus. And so again, I forgot my outflow. Here's your outflow. All right, so again, you adjust this inflow of water, and you're going to get an outflow of water, but you keep a constant head here. That's, you can measure it typically from a piezometer of some sort. Okay, now the soil sample itself is going to have a length L. Okay, and then the cross-section area is going to be, A, and we'll see that in a derivation in a second. So after constant flow is achieved, water is collected for some time or some duration T. So you're gonna collect water, from this outflow in some kind of flask, okay? And then this water is going to have some volume, all right? So how do we derive this this kind of relationship that governs this behavior? Well, the volume of water collected is going to be equal to A times the velocity times time. Okay. Now this comes from, originally flow rate is Q equals AV. So what you can do is from Q equals AV, you've got Q is just volume over time, right? This volumetric flow rate. So the time value gets multiplied over to the other side of the equation, okay? Now you can re-express this as area times, now instead of V, you can say hydraulic conductivity times hydraulic gradient, and then times time, okay? And again, A is the cross-section area of flow through the soil specimen. Okay, so it's your cross section of your soil specimen, and it's the area that the water is flowing through. All right, and so we have this relationship here, and we also recall that hydraulic conductivity, which is I. Let's write that down. Hydraulic gradient. Forgive me, hydraulic gradient is I. And we know that hydraulic gradient is going to be that head over the flow length, okay? So it's that constant head H divided by the length of flow, which is just the length of the specimen, L. So we can piece all of this together, and we're going to get volume equals A times K times H over L times T. Now, this is a handy little formula. You can rearrange it and solve for whatever you like. Typically, you rearrange this and you solve for hydraulic conductivity K, all right, or coefficient of permeability, whichever vocabulary you wanna call it. And so you can rearrange this as volume times length divided by the cross-section area of flow times that constant head times time. And so this little relationship is what we use to calculate the hydraulic conductivity or coefficient of permeability, if you prefer to call it that, for a specimen during the constant head test. So that's going to conclude this background video. Our next video is going to explore a numerical example of this. So please hit like and subscribe and look out for the follow-up video.